Today I'm going to show you how to set up a Ultronic DSG1682DUPS gauge to operate a suction control valve or a recycle valve. In this case, we're going to use a recycle valve. In most cases, if these gauges are purchased in a panel, the panel is going to have detailed specifications about the gauge configuration listed in the drawing. Here we can see line item 2 is a DSG gauge 1682, configuration for a suction recycle valve with the basic configuration in it. But I'm going to show you the menu systems. For our test purpose, we have a 4 to 20 milliamp measuring device hooked up to this gauge, measuring the current loop on the outside of it. This can be emulated with any digital volt ohm meter used in 4 to 20 milliamp scale DC. So the first thing I'm going to do is I'm going to just set this gauge up. We're going to push menu and we're going to look at the main menu options. We can see that auto scan is off, and that is fine. Diff options should be disabled, but we're going to check, and they are. They're turned off. So I can go to the previous menu. We're going to set up channel 1. Now we're only using one channel for this, so we're going to default to channel 1. The units is in PSI. The filter is defaulted to 230. Most of the time, we never have to change that. Set points. This would be if we're using the switching functions that we want to trigger hard set points at certain low and high pressure values. For this gauge, we're not going to do that. Configure. Type. It's going to be pressure, and we're going to select range. Actually, we're going to go back up and we're going to tell it custom, because this customer is using a 4 to 20 milliamp. Now I'm going to scale this at XX, all X's with no decimal place, because this is fairly high pressure. There we go. So it can read up to 10,000 PSI. For the voltage, we're going to say 5 volts, even though this is a 4 to 20 milliamp. But we're going to use a 200 ohm resistor to convert that milliamp signal to a voltage. That voltage range is 0.8 volts to 4 volts. So now we have to scale our sensor. I've been told that the sensor for this job is a 0 to 250 pound pressure transducer. So we're going to change this low value, and this is the voltage that this gauge will see from the sensor, to 0.8, so that's 0.8 volts, and I'm going to say that it's 0. On the high side, we're going to change it to 4 volts, because that's the range of the sensor, as far as the voltage that this gauge will see from the sensor. And again, we've been told it's a 0 to 250, so we're going to change this high value to 250. The nice thing about this gauge is the longer you hold the button, the faster the values change. And we have 250 entered. And then we move the cursor to apply and hit enter, and it saves these changes. At this point, we can go to the previous menu. Gauge label. I like this feature because it's important when the operator is looking at the value displayed on the screen, such as this gauge, it tells us what that value is. There's default values programmed in, and they're under a numeric system. I happen to know that this is going to be suction pressure, and that's up around 50. So we'll just get up to the high 40s and we'll look. Starting gas pressure, 50 suction, 51 would be suction pressure, so we'll capture that. And previous menu. Bar graph. Bar graph is something that we do not need. We'll check it real quick. It's turned off. I'm going to leave it off, and it just makes the screen a little bit cleaner for this application. Previous menu. Calibrate. Now this is where we set our 4 to 20 milliamp current loop. I'm going to go down to loop cal, and we're just going to check it. So at 4 milliamps, I have a count value of 625, and right now the gauge is putting out 4 milliamps. And I'll show you what would change if I edited this. So it's critical that when you're setting up one of these gauges that you check these things. I'm going to raise these count values up quite a bit. And you can see now that it's putting out 5 milliamps. So if I back up, I'm going to start dropping these counts down. And we're going to drop it down where it's reading a perfect 4 milliamps again. Again, you can do this with any digital voltometer. And you would wire the voltmeter into the loop output terminals on the back of this gauge. That would be terminal 7 and 8. Okay, and we can see we're now at 4 milliamps. Likewise, we want to check the high side. At 20 milliamps, we are putting out a perfect 20 milliamps, but if you were off, you would just do the same exact thing. So now I can back out of this and go to the previous menu. And I am done setting up channel 1. We're going to skip channel 2 because we're not going to use it. Communications output. We don't care about communications right now, node address or baud rate. The only thing that I want to do on this screen is checking to make sure that, hey, loop is a true PID. And it is. So now we can go to the previous menu. Security I'm not concerned with. Control action. Control action states that the deadband is 0 and the action is direct and the mode is channel 1 is linked to a PID loop output. Now what I do want to do is I want to change this deadband to 1 pound. And you can see now that it is changed. And I can simply hit escape and I'm back at the main screen. So now we want to set up our true PID loop. This is the main home screen, and I'm going to use my up arrow to navigate until we see suction pressure. It says we're putting out 4 milliamps, and we are. And it says the current value is 53 psi. It says our set point is at 50 psi, our proportional is at 40, our integral is at 10, and our derivative is at 999, and it is in auto. This is a great starting point. Now, if we want to change any of these values, we simply push menu, and it moves the arrow cursor to the value that we may want to change. Example, I can toggle it from auto to manual and back again, and I push enter when I'm done. Now I'm going to push menu up to 50, and let's say if I wanted to change it, I just push enter, and I can again change it to any value I want. I'm going to leave it at 50. Menu again moves it to proportional. Now the faster you want your valve to react, the lower you make this number. 40 to 50 is generally a good place to start. If you want your output your 4 to 20 milliamp output to change faster, lower this value. If you want it to change slower, raise this value. The same thing on the integral. It's a way of fine-tuning things. But again, most cases, applications, 40 to 50 for the proportional and 10 seconds on the integral. We never alter derivative. I usually always leave them at 999. So in this case, we've told it 50 pounds is our target. So right now we're putting out 4 milliamps, but if I drop my pressure, if I drop it to 49, it should freeze our gauge because we're in a 1 pound deadband, remember. 51, same thing. Our pressure really shouldn't change. 49, our value should not change. But now if we go one more step closer, 48, now our value output starts to change. Now the longer it stays at 48 psi, the more this value is going to increase, simulating that it's trying to open up a control valve to get this pressure back in line. The further away I get from my target at 50 pounds, the value is going to change even faster. And we can see we're up at 20 milliamps right now. So this is a pretty fast setup. And now I'm going to simulate the pressure going up above 50 pounds. And we see that now the milliamp current is dropping back towards 4, thus it's trying to close the valve. Now there's a couple of other things that we can do in the menu system of this gauge. So from this screen, if I want to get back into the main menu, I would simply push my up arrow once and now menu, and I can enter in the main menu screen. Now I've got to find the right menu. Control action. Right now we can see our deadband here at 1 pounds, our mode, channel 1 PID, but also direct action. There are cases where customers have valves that work backwards, meaning they require a 20 milliamp signal to close the valve versus a 4 milliamp signal to close the valve, and likewise they require a 4 milliamp signal to have the valve fully open. In that case, what we can do is move our cursor from direct down to the action and change it from direct to inverse. And now I'm simply going to escape out. I'm going to go on and back to the PID setting screen. Of course, it'll work even if it's not there. Now we can see we have 55 pounds, but instead of the valve trying to close or the value trying to drop to 4 milliamps, the value is going to 20 milliamps. So we just reverse the action of this gauge. And this is rare that gauges or valves use pressure to close, but in some cases, especially up north where freezing conditions happen, it is very common. So it's always nice to have this action or know this because we can reverse the way the current loop reacts. So likewise, if I drop the pressure down lower, now we want the valve to open, but in this case, the number's going down rather than up. So I'm going to reverse this one back. To control, I'm going to go back to control action, and I'm going to change it back to direct. And save it. And again, we're at 44 pounds. Our valve is trying to open. The number's increasing. I'm going to drop or increase our pressure up above 50 pounds. And we can see real quick that the value starts dropping. that concludes this tutorial. Thank you very much.